descriptive statistic. Last lesson, we understand what is the statistic engineering, and we understand the population and sample. There is from the population to sample, we must have the relation probability, and from sample we have a statistic inference. And I show you what is the mean. Mean and median is the method location. Now today I will show you what is the lower quantile and upper quantile, and what is the inner quantile ranks. And I will show you what is the sample variance and sample standard deviation and sample rank. Sample ranks here is the from the minimum value and maximum value. Okay. Here is our book, textbook. I hope that you can read it and understand about the descriptive. This chapter about the descriptive statistics. Here's the sample mean. Is the location, right? The method location. Here's the sample mean and median. I give to you the definition of sample mean is here. Follow this formula, and median when we increasing order value, and x median is the x and a plus 1/2 or 1/2 x and over 2 plus x and over 2 plus 1 when n is even. Okay. Other measure location. Other location we have trim mean. Trim mean here is when we want to remove 10%, trim mean given by that's the TR. Here is a trim. The definition of extreme mean is they remove smallest, the smallest 10% and largest 10%. When we see the, where is the data? Where is data? Sorry, I don't remember where's data here. Where?
Trang số 5, cái bảng số 5.
Number 5. Okay. Here's a number 5. Here's the data, and we order increasing, so we remove the 10% smallest and 10% largest, so we have the 80% inside the ranks. And here is such as this data is right. We remove 10% here and remove 10% here, we have 80% inside. And from inside, we find out the sample mean. And that sample mean called the shrimp 10%. Trim 10%. We remove 10% is here. Eliminating largest 10% and smallest 10%. And then we find out the median. That's all. And we have the value here. It's similar. We have the 10% trim mean of for the with linogen group we have. So we have two trim mean, 10% trim mean. Example, we have this value. Can you find out the 10% shrimped mean for this exercise? I received a message from your friend when I send you this code. Your friend asked why I can't read this file. It's very easy. You open your Google Drive, right? And then you put upload the file that I sent. Okay. I don't remember much. I don't put it again. Sorry. I don't take it right here. I must be downloaded from the file. We have Python here. We download it. Why I can't download it? What happened? It's wrong because the CD is wrong.
I think I can see it. Yeah, number 1, 2, 3, 4, 5. Up to down.
1, 2, 3, 4, 5 up to down.
It's 5. Exercise 1. Yeah.
Exercise 1. Okay. Yeah. Example is here, right? Sorry. That I copy this to the here's our lesson. Exercise 1. Oh. Three point four. Okay. My computer had something wrong. Could you the screwdriver, please? 3.4. Happen here. But I think it's wrong. I saw you later because my computer have a problem. Can delete it. 3.4, you see? 2.5, 4.8, 2.9, 3.6, 2.8, 3.3, 5.6, 3.7, 2.8, 4.4, 4.0, 5.2, 3.0, and 4.8.
Teacher.
Yes.
I did this exercise. I send it in chat box.
Okay. Very good. Thank you. I download it right now. Let me check. Week 2, your my computer have a problem now. It have a problem. Quiz. Can't download, can't do anything. Can't download it. Review not available. Please download the file. My team have a problem. I don't know why. I don't know why I can't download this file. Okay. Sorry, my computer today is not work well. How do I do? What's wrong here? Invalid. Okay, 4.8. 4.8 is here. It's not true. Okay. Now I need to run this. Okay. Oh. Now I have to NP mean x. So you will find out the sample mean and the median, and x will have a median of x. Now we want to understand the stream, 10%, right? So we have to follow the discrete, and we stream eliminate 10%. Now you see that the sample now is short from small to large. So from this, we will find out the number size. I call it n. It's the length of x. Okay. Length of x is here. Here is n. Let me see that it is 55. So we see that the x n plus 1 n plus 1 over 2. Oh. Let me see. It's 3.7. 3.7 here is a median. It follows the definition. X equal n plus 1 over 2. So here is a median. Now we stream 10%, 10%, stream 10%, 10%. It means that we maybe we remove 2.5 and 2.8 and smallest, and remove 5.2 and 5.6. We call that is the 10% lattice. However, we know that what is the 10%? We have the function is the x quantile, 0.1.
12%.
10%? No. Let us check. Maybe I have to use NP number on type. Now it's a 10%. 10% is 0.1. Oh, not 0 here.
Sure.
0.8.
Sure.
Yeah. 0.8.
It's
Yeah.
12%. It's 12%, not 10%.
10%. Not 12. 10%.
In exercise 1.1, it's in 12%.
I know. I now illustrate what is stream 10% smallest. And now I want to remove 90%, 10% largest. It means that I have to find the quantile of x, 90%. 90% here is 0.9. Okay, 0.9. The value is 5.40. 5.04. So we remove 2.2, 5.2, and 5.6. So when we stream two values smallest, 2.5 and 2.8, and 10% largest, 2.2 and 5.6. So we have this. We have this value. We have the new. Is stream, right? Stream. Eliminate here. And when we stream the data, we have a NP mean X stream. Here is a 10% mean stream 10% mean. What is the difference with here? Here 3.7.8 7.86. Here's 3.7, nearly 3.7. So now about the theory and practice, could you understand? Oh my, what is the step here? I can't quiz this. How do I show you this? Okay, now do you understand what is the stream? Mean stream. 10%. Okay, stream mean. It's a follow like this. Similar, we can definition of a stream mean 20% or 30%. Here's the exercise you work at home. Stream mean. Now we move on to the measure variability. Measure variability show you the difference of the data with the mean. Example, there are two students, A and B. Student A have the mean score is 7, and student B have the mean score is 7 too. However, one student quite stably and stable, and the student B change the score a lot. So what is the metric to show the stable and change of the score? It is called the variance or variability. And we have the The concept is a sample standard deviation. And the concept is a sample range. Sample range is a value of x max minus x mean. Example, my computer. Okay, it's good. And P max, okay, X. We have the maximum point X here. Here's X. We have to find out maximum. Oh, maximum here's a 5.6, right? 5.6. And P mean X. So we have the minimum is 2.5. And when we consider the range equal maximum of X minus and P minimum of X. So now we have a new concept, is a range of data. And range here. The range here is a 3.0, nearly 3.1. It's a range of big. Now we write down on the chatting box, what is the range? The range of data. Can you show me what is the range of data? Each person of our class, please write down on the comment box the range of data. Could you? Sample range of data is x max minus x mean. Now we would like to show you the do you see that's the highlight? Highlight is here.
Có cái bút highlight ở trên thanh công cụ của ạ.
Where this is here?
À không ạ, bên trên ạ.
Where?
Dưới ạ, cái đấy, cái thanh đấy ạ. Ở cô tại bên phải. Không, cô ấn vào file đấy ạ. Ấn vào đây ạ.
Okay.
Ở bên phải, cái dòng đây đúng rồi ạ.
Thank you. Yeah. Sample standard deviation. I often use a preview, however, it's hold, so I can't do it. Sample standard deviation. Here's a definition of sample variance. It's denoted by small s square. It's given is a s square equals sum xi minus x mean. X bar here is the x mean. Total square over n minus 1. Here you have a notice. It's not over n. X bar is x1 plus xn over n. However, sample variance is over minus and minus 1. Why? We have the theory in the previous chapter. The sample standard deviation. The difference here is the variance. Variance is S squared. And here is the sample standard deviation is S. It's the root square of S squared. Okay? And it's the positive square root of S squared. And so when we talk about the sample variance, it's a n sample standard deviation. Always it have the positive value. Okay, so here's the definition. From this, we can compute NP, STD. ST is denoted for standard deviation. Standard deviation. X, we have the standard deviation, or we can compute for I in range and okay. 10 equals 0, temp equal temp plus I from 0 to, here's a x I minus, follow the definition is a minus x min and b min, right? X total square, right? So we have the sum. Oh, what is it? Oh, sorry. Oh, yes. NumPy. Let us check it. What is the range? Is it wrong here?
Range, not rank.
Range. That's not true. Let us check it.
Cái bên trong ngoặc đấy có phải là một list.
I use
là list gì?
So sorry. Now I understand why my computer have a problem, because I use Wi-Fi of my neighbor. So it's too slow. Here is I from 0, right, to n here. Okay. Yeah. What is wrong? In ranks. Let I check out. 15.
Thế thì là 2 chấm ở giữa thì phải gọi.
No. No. It's not true. I don't understand why. happened? Oh, okay, I see. Here is the square like this. Where's N? Where's temper x1 y strong for I in first time not done nothing wrong. Okay, we have the formula to find out in the practice. We use standard deviation here. Or if we want to find the variance, we use the x bar. And p bar x. Here's the variance, and here's the standard deviation. Okay. When we know the formula, we can do it. However, I don't understand why it's wrong here. I don't understand at all. Why it can't? For I in RAM must be. I always check it. For E in range 10, green I. Okay. So for in my computer maybe have a problem, right? So this is so strange. It's so strange. For the comment for in my computer maybe have problem. Maybe in the future I will fix this error. Okay. So you know that here's a standard deviation. Here, if we have the mean, sample mean is 8, we take each data minus the mean and square. We plot from 1 to n. So we have the sum. And we over n minus 1, we have a variance, sample variance. And we take the root square, we have the standard deviation. Here is the example. We have the data, we can find the sample mean. From sample mean, we find out the sample variance. And from, you should remember, is the size of data here is 10. So we have that divide by n minus 1, so it equals 9. Many students do the exercise often over n. It's not true. You must be over 9. Okay, n minus 1. Here is the standard deviation. It's S. And how we compute it? I have shown you. Why? We must use the standard deviation replace for variance because the unit, if x is have the unit is a centimeter, so variance is a square, so the unit of variance is a centimeter square. It's not true for the data, so people take the square, root square. Root square here have the unit. Now it's the unit of standard deviation and unit of data have the same. Okay, So now you understand why people use the standard deviation replaced for variance. From the population, we have several population parameters. We want to know population mean and population variance. However, we can't have all the data of population. So we use the sample. We take a sample, randomly sample, or some way we have the data is called sample. And from the sample, we find out the two value. The first is the sample mean, and the second is the sample variance. And we hope that the sample mean and sample variance can estimate for population mean and population variance. The method to find out the population mean and population variance is called the statistic inference. And here's the exercise you work for this week. Now, I move on the discrete continuous data. Before I give to you the lecture 5, discrete and continuous data. Do you have any question for the sample variance and sample streamed mean? If you do have any question, please turn on your microphone and talk to me or write down on the chat box. Do you have any question to me? Download it. Do you have any question? Okay. I hope that you can understand two concepts. First is the stream mean, and the second is the sample variance, sample standard deviation. Okay. 10-minute break, please. We will continue as the 11:10. Okay. Hello, we continue again. Now I can fix the command for previous code. I don't understand why it not can run well. Now I show you the data is x here and n is here. N is the sample size. So you know that n equals 15 and the rank is it means minus x marks. And you know that I want to find the mean. A sample mean is a 4e in ranks n. Ranks n. Okay. I use the tempo. Is the variance the temporary. Is a tempo equal tempo plus xi, right? And now the my mean x mean x bar equal tempo over n. Okay, so it run well, right? And x bar here here the value is correct. I don't know it's correct or not. So I will check by the function of numpy mean x. Oh, sorry. I forgot to assign is equal 0. Here, x bar is a 3.78 ccc and it means 3.78. So here is true. If you use this function, you can apply it immediately. If not, you can write by yourself when you know the formula of sample mean. Now I check the variance. The variance I use where is the variance? Okay, now I will code the variance. So sample variant, I assign the tempo variable equals 0 for e in n. Here's a tempo plus tempo x minus x bar, right? Minus x bar square, right? And sample s variant. X variant. X variant is tempo over n minus 1. Okay, so we'll show us X variant. Here's a variant. Now we check the NP variance of X. You see that here is the way we over n minus 1, we have this 0.94, and here's a 0.87982. And you see that, oh, variance that follow formula and variance of the function of numpy is different. What is different? Because variance of x here, the function over n, not over n minus 1. If we see that, it's a bar here, x bar. If I don't divide it in n minus 1, I use the tempo, it's over n, it's the same bar. Yeah, x bar here is over n, and variant of the Python pupils use is the same value. However, when we use sample variance, we have two over n minus 1. So you have take that term n over n minus 1. So it's the same. What is true? We follow the theory. Is follow this value, not about the variant only. Why? About the theory previous lesson, I will show you that why people use the sample variance by over n minus 1 is not over n. And when we use the computer, when n is very large, n is very large, the variance here and variance here is the same. However, with n small, they are different. Okay. Now, lesson 5, discrete and continuous data. People divided the data in two types, discrete and continuous. What is the difference with discrete and continuous? Discrete, what is discrete? And what is continuous? The values of data we can countable. When we countable, so it calls the discrete data. You study English, you know that the countable noun and uncountable noun, right? What is a countable noun? Is the countable data. And what is the uncountable noun? It calls uncountable data. And countable data is called the discrete. And uncountable data is continuous. And the difference with the discrete and continuous is that the data continuous must have the units, such as the time about the milliseconds, second, minutes, day, etc. Right? And about the meter, about the long is the meter, kilometer, and such as. It's like that. People call that the continuous data. And we have the new definition. Concept is the sample proportion. When we consider about the data and n unit involve the data, and it is defined the number that category 1. The data have two categories, and n minus 6 fall into category 2. So n over n is a sample proportion category 1, and 1 minus n is the sample proportion in category 2. Example, our class have 60 students, and 50 students are men. Is called category 1, and 10 students fall into category girl or category 2. So we have the 50 over 60 is 5 over 6 in the sample proportion in category men, and 10 over 60 is the sample proportion category 2. Okay, here is an example. There are 50 patients may present the sample unit, and if 20 out and 50 experiment an improvement in stomach ailment common to all 50. After all were given the drug. So we have a proportion 20 over 50 equals 0.4 is the sample proportion, which is the drug was success. And 1 minus 0.4 is 0.6 is the sample proportion for which the drug was not success. So we have a new concept, it's the sample proportion. If we have several category, we consider the number involved the category 1, 2, and K. And we have the fraction, the number support for one category over the number of sample. We have the sample proportion, okay? And if we have the binary data, it means that we denote two values, 0 and 1. 1 is mean the event A happened, and 0 is the event A doesn't occur. Such as we consider how many sample proportion of students pass this course. If a student pass this course, we count is 1, and I consider one student. If he pass course, we call that is 1. Denote is 1. If he doesn't pass this course, we consider it's receive the value 0. Now we want to find out the sample proportion, so we sum all the xi here. The number n is the number of sample, and x1, x2, x50 only receive two values 0. If it not pass, and 1 it's pass the exam, and we plus here we have the proportion. Sample proportion is 0.4 is the called the probability sample proportion success, and 1 minus 0.4 here is the sample proportion not success. Okay. This theory is continuous studies in a chapter. It is the general is found out by mathematician called his name is Bernoulli. I think that you study in the high school about the Bernoulli formula, and Bernoulli is give to us this sample proportion. It is the definition of probability. Okay, you can read more in the textbook. Now I change to the next lesson: statistical modeling, scientific inspection, and graphical diagnostics. And we want to understand what is the parameter of postulate model. Now we have to plot some data. We have to plot some data. In previous lesson, I have shown you the way to exploit the data, right? Right, this here. We use this packet. And BLT plus plot dot plot x. Okay. Here, we have just draw the xi, the value here. And we call that is describe data. Okay, from this data source, mean, max, and the value inside from 2.5 to 5.8. Okay, follow this finger. It's quite big. Now, what's that? Open. Now we want to explore data analysis. How does we use histogram? Okay, histogram. PLT his X. Here's a histogram of the value of the data X in the exercise 1.1. Okay, what is the meaning of histogram X? It shows that the value 3, the value 2.5 have about the 3.3 here have a 2.2 data. 3.5 is 2 data, and 4 have 1 data, and from 1 to 0 and 4.5 have no data, and so on. It means that horizon axis is the value of X, and the vertical axis is the frequency appear of data. Okay. Now, you will practice another data in the exercise and show us the histogram and plots like this. And continue data is use the box plots. Box plot. Where's box plots? Yeah. We have the new concept is the box plot. Box plots help us to find out the outliers. The outliers is the value restraint. It's outside of the normal value of data. And can I copy it? I don't know. Okay. There is the finger. Here's the nicotine data from the example 1.5. Here's the data. And when we draw a graph, box plot, what is the finger tell us? The meaning of the data here. Can you tell me? Can you tell me when you see this finger? Do you know any information from this data? If you can tell me, please write down on the chat box. If you don't understand anything about this finger, please write down U. It's D. It means don't understand. Okay? Could you interactive with me? See, look at the nicotine fingers. If you know and understand anything about data, please write down on the chatting box. If you don't understand, please write down G. Can you? D. The other student, our class is quite crowded. There are more than 68 persons, pupils, students here. Only 5 students tell me D. The other student